Now, today we are going to discuss the basic properties of electric charge. So, electric charge, suppose in kinematics we have one assumption. So what is that? Suppose a train is moving with 60 kilometer per hour. 60 kilometer per hour. So, train has many compartments. Which of that is moving? Which of that moving with the 60 kilometer per hour? So simply the assumption is the total train is considered to be a point object. How can we imagine that much of a huge very big length of train as to be a point sized object? Why? Because the traveling distance, suppose train has traveled 1600 kilometers, but what is the length of the train? Let us say 1 kilometer. Assumption, let us say 1 kilometer. So 1 kilometer object traveled 1600 kilometers length, right? So when compared with the distance traveled by the train, the size of the train is considered to be as a point. Then train is traveling means a point is traveling with 60 kilometer per hour. That is one assumption. Similarly, in case of electric charge also, the charge is going to be considered as a point charge when compared with the distances between the charge sizes, right? So that is why here the whatever the charge, suppose I say some one coulomb charge, that 1 coulomb charge, if you distribute, how much it could be, mean how much area it can occupy, like that some doubts we can get. But the question is, irrespective of that, how much space it can be occupied, so in how much big size of body it is there. So irrespective of all these, we consider the total 1 coulomb of charge as to be a point charge, that you have to remember. Now let us go to that. So if you remember, what is the basic property or basic properties? First thing is additivity of charges. For example, additivity of charges, if you want to remember and understand very easily, if there are two masses, suppose 5 kg and 10 kg, what is the total mass means? What do you say? So definitely it is simply 5 plus 10, 15 kg is the mass, total mass. Additivity of mass, that is. But when it comes to the additivity of charges, we know that charges are two types, right? One is a positive, another one is a negative. Whenever you are making it, so to add our additivity of charges property you are talking, then Q is equals to Q1 plus Q2, you are going to write it. If the Q1 is in a negative, or if Q2 is a positive, along with their sign we have to add it. Suppose if Q1 is I will write Q1 equals to minus 3 coulomb and Q2 equals to 5 coulomb charge. What is going to be the total charge? So simply add them, means minus 3 plus 5, that is going to be the 2C. 2 coulomb of charge is there. 2 coulomb of charge. Is it a positive charge or negative charge? Because higher sign convention is a positive, na? That's why you are going to take it a Q as to be positive charge. It is a additivity of charges. Simply we are adding, right? So that's why like mass example, very similar. In that case also, total mass equals to, you can write as m1 plus m2. If that is a 5 kg and 10 kg, total mass you are going to write as a 15 kg. Then what you are finding the difference between the mass and the charge? Mass is going to add along with the sign because it has the different kinds, whereas it comes to the mass, you are not you need not to discuss the sign of mass. Just you can add it. That is the one similarity what you can understand, mass and charge. Second one is, second property, this is the first property, basic property what you can know about the charges. The second one is charge is conserved. Charge is conserved. Charge is conserved. Charge is conserved. So what we are understanding in case of charge is conserved? Charge is conserved, if you are understanding, what is the meaning of that? We know in physics there is a much importance to the law of conservation. Law of conservation. Law of conservation of what? Law of conservation of mass, law of conservation of momentum, law of conservation of energy. Like these laws for conservation are very important in physics. Similarly, here is also law of, conservation of charge, or charge is conserved, we can say it, right? So what is the meaning of that? The charge is neither be created nor be destroyed. It can change from one body to another body. That's all. We are not giving any new thing, new born thing to another one when we are charging a body. Previously also we have seen in the previous videos what is the meaning of charging of a body, right? Electrification, that all those we have discussed. In that we if you want to understand that, once you can go back to the previous video and check it. Now here it is, charge is conserved means from one body to another body the charge is transferring, but it is not generating, right? So that is why we are saying it, charge is conserved. The Q is going to be the constant. Total charge is going to be the constant whenever it is because when it is happening, the transfer of charge, in one body it is reducing, another body it is increasing, but total if you add, it is going to be the same. That's why charge is conserved. And one more point we can remember is, sometimes in some other cases we can remember that the neutron is going to be divided into proton plus electron. Proton plus electron. So if that is the case, what will happen? What is going to be the net charge? We know that neutron is electrically neutral. It is having zero charge. Why we are saying zero charge? Electrically neutral it is. The whenever it comes to the proton is going to be the positive charge and electron is going to be the negative charge, right? So then positive plus negative, total again what you are going to see? Zero. And previously when you talking about neutron, what is the charge? Zero. So we can understand that even sometimes in the reactions neutron is separated, or neutron has reacted to form one proton and electron, the electrical property totally is going to be the neutral. So that we can observe when charge is conserved. When charge is conserved. And another property is charge is quantized. Charge is quantized. Charge is quantized. Oh, so what is the meaning of quantized? Whenever we are talking about mass, surely we can understand mass has a quantity, right? Then charge is also having quantity. So that to say, we are saying charge is quantized. Charge is quantized. So how can we know that charge is quantized and how can we calculate? So that definitely Q is going to be calculated plus or minus n into E. Plus or minus n into E. So whenever we are saying that n is going to be in place if there is no charge, 0 or 1, 2, 3, like this number you can have, but this n should not be like 0.5 or 1.5. It should not be like this. Why it should not be like that? So whenever you suppose you are purchasing fruits, if you ask the person, okay, seller, so give me 1.5 banana, 1.5 banana. So is it senseful or senseless? If you ask one, okay, that's fine. If you ask two, okay. If you ask dozen also, no problem. Or if you want purchase all also, no problem. But how can you ask half of the banana? Half of the banana, it's a senseless, right? No one can buy like that, okay. So but the similarly point is, whenever you are saying, in the previously we have already known in the types of charges video, right, we have known what is the charge of one electron. 1.6 into 10 to the power of minus 19 coulomb, right, minus 19 coulomb. If that is the case, what you can remember, if charge is one electron is having that much of charge, if you say q equals to 1 coulomb, 1 coulomb. So what is the SI unit of charge? SI unit of charge is coulomb. SI unit of charge is coulomb. So if you say what is the meaning of 1 coulomb? What is the meaning of 1 coulomb? So if I ask you what is the meaning of 1 dozen, what is the meaning of 1 dozen? What do you say? Definitely you will say with one number, right? 1 dozen means 12 number, right? So 1 mole equals to some number you say, and 1 ton equals to, you say something, one number. 1 kg, again you are going to say something, some number, like it is equal to some number, right? Equal to some number, like that. What is the meaning of whenever you are saying charge is 1 coulomb? Charge is 1 coulomb. So then here it is q equals to plus r minus n into e. So why we are writing plus or minus? Because the charge means it may be proton or electron, right? It may be proton or electron. So that is why what we can say, you can say if it is a proton, what you will write? You can use the plus sign. If it is a number of charges or electrons, you can write a minus. That's all. That's why to say that in a single thing you are writing a plus or minus n into e. If two charges are there, because one electron is going to have how much charge? This much. So then if there are two electrons into 1.6 into 10 to the power of minus 19 coulomb, right? So if this E value is already known as 1.6 into 10 to the power of minus 19, that should be multiplied with the integer, just 0 or 1, 2, 3, 4, like this, just you can multiply with the number, because already we know what is the meaning of E, what is the meaning of that E charge, right? So then if you say half, just imagine it, q equals to half into 1.6 into 10 to the power of minus 19 coulomb, 1 by 2 or 0.5. Is it having any sense here? No sense at all. Why? Because you are saying half charge, half electron. How can you say that half electron? The minimum part what we can divide in atom up to now in our subjective discussion of electrostatics, just electron, proton, like that, right? So up to that only we are going to discuss. That's why half of electron, that charge you are saying means it is like half banana you are saying it. That's why it is a senseless to say number in case of 0.5 and like that. Instead you can say as an integer, right? So these are the basic properties, and you try to know some information regarding this. Then what is the meaning? If 1 coulomb charge is there, how many number of electrons can be there? Like 1 dozen means 12 you calculated, okay, that's fine. What is the case? N equals to 1.6 into 10 to the power of minus 19 coulomb, and 1 coulomb charge, per 1 coulomb charge how many can be there? So that you can easily calculate. So see this, 1 by 1.6 into 10 to the power of minus 19 equals to n number of. So that if you calculate just simply 1 by 1.6 into 10 to the power of 19 equals to n. Then 1 by 1.6, how much it is going to be? That you can calculate almost 0.625 into 10 to the power of 19 number. So these many number of electrons or protons can be there if you say 1 coulomb of charge. So whenever you are saying 1 coulomb of charge, you are saying 0.625, or if you want say 6.25 means you reduce 1 0 here, 6.25 into 10 to the power of 18 number of electrons, or 18 number of 10 to the power of 18 number of protons, if it is a positive charge or negative charge. That should be maintained very clear in our mind whenever you are calculating or talking about what is amount of charge. So these three are the basic properties of charge. Based on this, remaining also can be derived, and in some reference books or in some volumes, okay, competitive volumes, some other properties which are derived from these only can be maintained, right? So in the next class we will see what is the Coulomb's law of electrostatics force, right? Thank you.